Alright, this is our fifth and final installment of using loops and sequences to learn about programming. In this problem, we are going to use while loops to sum arithmetic sequences, although there's nothing that requires you to do an arithmetic sequence. You can just change the formula and inputting of D, like I mentioned in lessons 3 and 4, to sum geometric sequences instead. And if you want to, you can just create a single program with a menu to sort of make two subprograms. That would probably be a nice, interesting activity for some of you who are looking to stretch yourselves. But here we're going to answer this problem, and I believe this problem is from lesson 3, where we summed the first 100 terms of the arithmetic sequence 1, 2, 3, 4, 5, 6, and so on up to 100 to verify that it was 5050, like the kindergartner, according to story, the kindergartner Euler or Gauss, I can never remember, did. So when I write this program, I am going to introduce a few, or I'm going to rather not introduce bugs when they come up, and then when we troubleshoot at the end, we're going to figure out what the two problems are and fix them so our program is good. So here we're going to create a new program. So we already have an arith sum program, and so I'm going to create a program called sum arith. You can come up with a much more clever name than I have. That would be wonderful. So we're going to put our same 3 lines as always. Clear the home to make it look clean. And then we are going to put our name on it. And we're going to pause so they can enjoy our name before that we go on. But again, sometimes the pause command creates some confusion, so I tell my users to press enter. Now I need 3 inputs. I need a sub 1, I need D, and I need the sum. So I'm going to input, ask the user to input a sub 1 equals question mark. I'm going to store that in A. I'm going to ask them to input common difference. And I'm going to store that in D. Now, this is the first line that would be different if it was a geometric sequence. So instead of common difference, it would say common ratio, and our convention is to store that as R. And then we're going to ask for the sum. Sum that we want to meet or exceed. And I'm going to store that, because I'm so clever, I'm going to store that in S. Alright, and so just as I did in a previous program, I need to initialize. I'm going to put 0, and I'm going to store that in T. Because we found it as a bug in the last program that I wrote that instead of input here, I put display, and n was already set to 100 from a previous program. So it ended up running 100 times. So here I'm going to initialize the total to 0. And now I want it to run while the total t is, and we've done number 6, less than or equal to s. So while the total is less than or equal to the sum that we're looking for, it's going to take the total, or it's going to take the next term, this. We need to also initialize my counter, I. 1, store that into I. So I'm going to take the term a plus alpha I minus 1 times d, the common difference. So here again, whenever I use d, it sort of triggers my red flag. If I was summing a geometric sequence, then this term here would be different. Alright? I'm going to add that to t, my running total, and I'm going to store that in t. So initially when it runs, it's going to say 0 is probably less than my sum. It's going to find the first term, and it's going to add that to t, which is 0, and store that in t. So our new sum is our first term. Alright? And then we need to increase our increment, I plus 1, and we're going to store that in I. And then we're going to end. So this will run until our t exceeds our sum. And now we're going to display our answer. And this is going to be a multi-line display, so I'm going to use several commas because TI is not very good at this. So I'm going to program display, and I'm going to say you typed it too fast. You misspelled it. You need, and then how many terms do I need? What was my counter? My counter was I. But because I'm going to use it as a number, I don't want to put it in parentheses. Otherwise, it'll always say you need I, comma. Now I'm going to go back to terms for a sum Now I know that I'm back to my quotation, so I need to close my quotation because I need a new line. Comma tells it a new line. For a sum to be, comma, and the sum that we asked for was S, so S or above. Alright, so let's quit, and we're going to run this program with these three inputs. And we know we should get 100 terms. So let's go ahead and see if we get this. It's sum arith. It's by me, the math prophet. A1 is 1. Common difference is 1. And I want the sum to be 50-50. Now, I know it will be exactly 50-50, so we're going to see what I get. It says you need 102 terms for a sum to be 50-50 or above. Now, we know this is wrong. We want this to be 100. So the question we need to answer is, why is this coming out too high? And I told you at the top that I'm going to introduce 2 bugs into the program. And so here we're trying to debug our program. One of them is easy to determine and the other is not so easy. The first, I'm going to go edit. The first is we know that it was going to be exactly 50-50. 5,050. I like to say 50-50 from the Terminal movie with Tom Hanks. But so here, when it said 50-50, or 5,050 was our sum, less than or equal to 5,050, it was true, so it continued to run. But it should not continue to run when it's equal. So we need to change this symbol to strictly less than. Alright, so now if we do that, let's see if it's fixed. 1, 1, and our sum is 5,050. Alright, now it says you need 101 terms for a sum to be 50-50 or above. So now the question is why is there an extra term here? We got rid of 1. We're going to get rid of the other now. The other is a little bit more difficult. And it's the way a while loop works. And so it's why some people prefer repeat loops. So here, when it was the last term, the 100th term, my sum was 4,950. It was less than that. It went through. It got to the 100th term. And it went back here, 50-50. That was the 100th term. But it added 1. So I'm 1 too high. So what I need to do here is, to make it easy, I'm going to just subtract off that extra 1 right after the end. That's always going to exist. So I'm going to do alpha I minus 1 and store that back in I. So it's just going to remove extra 1 that was added on the loop when it was done. So now when I do it, let's see what I get. 1, 1, 5,050. And I get, you need 100 terms for a sum to be 50-50 or above. So that completes your using for loops and while loops to do arithmetic and geometric sequences.